All right, you guys, this right up here is kind of math language. Most people look at this stuff and then skip and say, just please teach me how this works. But I'm going to quickly go through this and then show you how it works. They're talking about roots up here in a roundabout way. And you remember a root is what gives you an x-intercept or a solution. So if my factor is x plus 3 or x minus 3, we'll say, right? And then my root would be 3. And they're kind of showing that down here, right? They're saying, hey, what if we have a factor of x minus a linear factor in this case? It just means everything's to the first power. What happens if I plug in a, or up here, what would happen if I plug in 3, right? What would happen if I plug in 3? Well, if I've got this equation, that means my factor times q of x plus r, and q of x is just the quotient, what comes out after you divide. That's what we were practicing on the other page, right? If I plug it in, well, if I plug in the factor, if I plug in a here, or if I plug in 3 up here, a minus a is 0, and all this disappears, and all I do is get a root, right? So in the end, when I plug that in, my answer is r, the remainder, right? So if your remainder is 0, that obviously means you're an intercept. And I realize it's kind of a long way to explain this kind of math languageese up here. But when you add it to the fact that when you don't have a remainder, you actually have a factor, that gives us a clue to how to figure out whether something is a factor or not. And that's what we're doing down here. We're trying to find out whether this right here, this is a factor of this. If x plus 3 would divide into this evenly. We can either do the long division, or we can do synthetic division, because we're allowed to do synthetic division when we're to the first power. So our goal is to take a polynomial and totally factor it out. So I want you to see that. All right? So synthetic division is how we start. So we're going to start with synthetic division, not with a factor, but with the root of that factor, which is just going to be the same thing with an opposite sign. We list all of this. So we're going to list all the coefficients, make sure there's no breaks. 3, negative 4, negative 12, and we're going to do our synthetic division again. So we drop down our 1, we multiply, we add, negative 3 times 0, we multiply, we add, and look, sure enough, I get a remainder of 0. That means this was a factor. I knew a fact. All these right here, you drop that, since we divided them all by the x to the first, those all cancel out. So that's, this goes down 1 to 1 x squared minus 4. So that's the root that we have after we divided this out. And if I'm going to list both the roots, really I have x plus 3 and x minus 4. We know this factors again, so let's go ahead and list this in factored form. Instead of listing as standard notation, we're going to say p of x is equal to, this guy breaks into x minus 2 and x plus 2, and then we have x plus 3. So we use synthetic division to divide this factor out, and then we factor what remains, and we write it in factored form. And there it is. This right here is the same as the original equation. If you graphed them both, they graph the same. We're going to do a couple more of these, and all your factoring situations come to play in here. So we're going to do it again. Here we go. We're going to use synthetic division. Instead of dividing by the factor, we're going to divide by the root, negative 1. We're going to list out all our coefficients, 1, negative 4, negative 6, 4, and 5. Just really quick, I'm going to make sure there's no breaks. Fourth power, third power, second power, first power, 0 power. And there's no zeros I need to place in to hold a place value. I drop this, drop the first term, multiply, add all the way down. Multiply, negative 1, add negative 5. Multiply 5, add negative 1. Multiply 1, add 5. Multiply negative 1 and 5, get negative 5. And we add in, hey look, once again, we have no remainder. That means this was a factor. So I'm going to move over here and list my factors. I got my original factor. I'll write it as p of x equals x plus 1. And then I'm going to list these factors. And I kind of know what's going to happen. There's 4 terms over here. So I believe we're going to have to factor by grouping. So I'm going to put this in kind of a bracket over here so it stays separate from the original factor over here. And instead of being to the 4th power, that's to the 3rd power. So I have x cubed minus 5x squared minus x plus 5. We got 4 terms, so I'm going to break these apart and try to factor these by grouping. Alright, so I'm going to keep my x plus 1. And I factor out x squared. That gives me x minus 5. I need to turn that into an x, so I factor out a negative 1. That gives me x minus 5. Oh, there's a lot going on here. So if we list them, p of x, I've got this guy, I've got x plus 1, I've got these guys that factor out of that binomial is x minus 5, and I've got this x squared minus 1. We got that alert going on right there. Wee-oo. Right, we've got x squared and perfect square, difference of perfect squares. So we got to do one more factoring situation. So I'm going to take this guy and put it up front. X plus 1, x minus 1. I'm going to write these two. X plus 1 and x minus 5. And I could just write x plus 1 squared, but I'll accept it like this, right? Because we see there's 2 of them, so I could take one out and put a square. But for now, that's the answer. There's one more we're going to do on the back. It's right here. And we're going to go one more time. Same process. And then I'm going to leave this guy for you guys to do. Alright. So again, not the factor, but the root. The root is negative 4. And let's list these out. So I have 2. That's x to the 4th. 8 on the x to the 3rd. And look, we're missing one in here. There's no x squared, so I have to hold that place with 0. And I have 2 and 8. And let's work through this. I drop it down, and then it's just multiply, add all the way across. Multiply, negative 8, add 0. Negative 4 times 0 is 0. 0 plus 0 is 0. Negative 4 times 0 is 0. 2 plus 0 is 2. Negative 4 times 2 is negative 8. And hey, it works. My remainder is 0. So since that was a 4th and we divided a linear equation out, that goes down to 2x cubed. And our constant's over here, so that's plus 2 for the one factor. And my original factor is still in there. Still x plus 4. And I'm going to factor a 2 out of here, right? GCF. So let's bring it up front. X plus 4. X cubed plus 1. Alright, you guys should recognize this after all the practice we did in class. We did 16 of these. Perfect square, I'm sorry, perfect cube, that's the sum of cubes. So here we go. I'm going to list them all. I'm going to list this guy, 2, I'm going to list this guy, x plus 4, and then I'm going to break that down into the factored form of the sum of cubes. Remember the cube of that plus the cube of that, so that's x plus 1. This squared goes here, x squared. I put my minus sign and multiply these guys together. 1 times x is just x. Put my plus sign, and that squared is 1. And there's your answer. Alright, I'm going to leave this guy for you guys to do. And when we come back to class, we're going to get to work. Good luck, you guys.